handle thousands of cables in a single simulation.
Okay, Sebastian, welcome to the EMA studios. Why don't you tell me about what you do at EMA?
Yeah, so I'm a senior scientist and product manager here.
How have you helped customers that have automobiles with lots of cables in them specifically?
The really unique thing about EMC Plus is the combination of our FDTD solver and transmission line solver. That means that we can tackle full platforms at a very computationally efficient way. Just being able to assign cross sections of cables to mesh routings means that we can handle thousands of cables in a single simulation. Computational efficiency from hybridizing that transmission line solver and FDTD solver is even more accelerated by our GPU capabilities as well. That just means we're solving these gigantic problems in timescales that are minutes to hours rather than days to weeks.
You were talking about full platform. So I hear people talk about full platform, and then when you look at what they did, it's a very simplified shell of the vehicle. Like a lot of the structures in the CAD aren't there. There's just a couple of cables. Is that kind of simple shell what you mean when you talk about full platforms?
No, definitely not. Another advantage of like how we go approach this is the FDTD meshing is very forgiving. That means that minimal amount of CAD cleaning is needed to include that full mechanical CAD, not just the shell, all of the chassis, throw the seats, the dash in there, the ECU enclosures, have very accurate harness routing throughout each subsystem. So when we say full platform, it's real full platform.
You said thousands of cables earlier. That sounds like a stretch. I mean, nobody really simulates with thousands of cables, really, do they?
Yeah, I mean, we've been doing thousands of cables for years now. Maybe it's even accurate to say a decade or more, with lessons learned from doing thousands of cables on an aerospace platform. We've been applying that to automotive lately. Again, the hybridization of the transmission line and FDTD means that we can have these complex cable bundles, literally dozens, sometimes even pushing 100, like per just a single bundle. And then when you extrapolate that to how the harness is routing throughout the entire vehicle, that easily reaches thousands of conductors, shields, and so on.
If you put that kind of complexity in, I would imagine you're approaching like 1 billion cells. Like how could that be computationally efficient?
Yeah, I mean, it is sometimes approaching 1 billion cells, but with that GPU acceleration that I talked about earlier, that means that it's computationally efficient to be able to handle that. Just like anecdotally, some of the full platform automotive that I've been doing recently were on that like 500 million cells, but we're still running radiated immunity in a matter of like an hour when we were doing multi-GPU acceleration. When we're getting on the course of 1 billion cells, multi-GPU helps us keep that like in the well under a day range still.
So I know a lot of people that I work with are switching to more agentic workflows where they're using Claude or Codex with what they're doing. Does that touch any of the workflows that you're talking about?
Yeah, 100%. Right now, the way that I'm mostly using different AI tools like Claude is for post-processing, but the huge initiative with EMA is being able to use that more in that kind of agentic fashion like you're talking about, of helping with that pre-processing, setting up the simulation, actually queuing simulations for like a sensitivity analysis, maybe an optimization, and then getting into that post-processing. It's here, it's now, being able to leverage AI and that like human in the loop engineering workflow.
For a lot of people, this is going to be new because I think full platform simulation hasn't made it everywhere yet. I think it's just getting started in the world. How would you recommend, if you're an engineer at a vehicle company responsible for the full platform, how would you get started with simulation and then flow from that and how you would start adding some of the agentic approaches once you get that going?
Yeah, so I think the first thing that you need to figure out is like, what is your end goal? If you're brand new to simulation, a lot of people think the first step should be, I need to match exactly what I'm getting in measurement versus my simulation. And when we're talking about a full platform, just because we know that we're the best at full platform doesn't mean it's not complicated. It's inherently complicated. If you figure out your goal and then you think of milestones of like what engineering insights I can get as I build up to my full platform with thousands of tables, every single bit of MCAD in there, then you can extract engineering insight through starting with simple models. So let's say maybe you are starting with that shell with a few bundles in it, but that's something that you can start in, simulate, and set up in well less than a day. Even if you do your first project, as you're building up your complexity, extracting engineering insight as you build that up, then you have that foundation of how to use our products, and then lead you into best paths forward for actually knowing what you want to do with those agentic workflows. I think having that fundamental understanding is important for when you're trying to go for that advanced automation.
Are people on their own if they want to start taking this journey?
Not at all. We have both internally a big team of application engineers and consultants that can help. We're also exclusively distributing through Ansys, Synopsys, and they have a large application engineering team around the world that is always going to be there to help as well.
Yeah, thanks for talking to me today, and thanks for all the great stuff you do advancing these technologies.
Thanks, Ben. Great to talk to you.